So how do we really know anything? I mean, seriously, how do we tell the difference between real knowledge, the kind that builds bridges and cures diseases, and just, wishful thinking?
That is the central question, isn't it? And for centuries, the main idea was verification. You just pile up evidence to prove your theory is true.
Right. But today, we're diving into Sir Karl Popper, the philosopher who just completely rejected that. He basically flipped the entire script on what knowledge is.
He did. He argued that we don't move forward by proving things true. We advance by trying really, really hard to prove our best ideas false.
It's such a counterintuitive idea at first.
It is. And for this deep dive, we're looking at his whole body of work, from his huge philosophical book, The Logic of Scientific Discovery, to his really profound political work, The Open Society and Its Enemies.
Okay, so our mission here is to unpack this core idea he had, critical rationalism.
Which is basically the thread that connects everything. The idea that we grow, whether it's a scientific theory or a whole society, by opening up our ideas to the harshest criticism we can find. It's all about eliminating our errors.
Let's get into it and find out why maybe we should all be asking the universe to prove us wrong. Okay, so when people hear the name Karl Popper, if they've heard it, they probably think of one thing, right?
Falsifiability.
Falsifiability. It's his big idea, his tool for separating what's actual science from what isn't.
Exactly. And yeah, you have to remember the context. This is the early 20th century. You have these revolutionary new ideas flying around. On one hand, you've got Einstein's theory of relativity.
And on the other,
you have these huge, all-encompassing theories like Marxism or Freudian psychoanalysis. And Popper saw a massive difference between them.
What was the difference?
Risk. Einstein's theory was incredibly risky. It made these wild predictions like starlight bending around the sun during an eclipse. If that observation failed, the whole theory would just collapse.
It really stuck its neck out.
It did. But then he looked at Marxism, or psychoanalysis, and he saw that they could explain anything. It didn't matter what happened. If a revolution failed or a patient got worse, the theory always had an explanation ready after the fact.
So a theory that explains everything in hindsight.
Ultimately explains nothing. That was his point. Their greatest strength was actually their fatal weakness. They were non-falsifiable. You couldn't even imagine an event that could prove them wrong.
So that's his line in the sand. A theory is only scientific if it's possible, in principle, to prove it false.
Yes. Falsifiability replaces verification. That's the engine.
Okay, I have to push back a little here for anyone listening who's thinking this. If we can never verify anything, if no scientific law is ever 100% proven true, doesn't that make everything just sort of temporary guesswork?
That's a fantastic question, and it's where he brings in the idea of corroboration.
Corroboration.
Yeah. Popper understood this basic asymmetry. You can see a million white swans, and it doesn't prove the rule all swans are white.
But you only need one black swan.
And the whole theory is gone. So we never get absolute certainty. But a theory gets stronger, it gets corroborated, every time it survives a serious attempt to falsify it.
So the more we try to kill a theory and fail, the more confidence we can have in it. For now?
For now, that's the key. It's temporary strength, not final proof. It's a conjecture that has, so far, survived everything we've thrown at it.
And just to clarify one quick thing that can be confusing, Popper was focused on these big universal laws, right? Like gravity.
Yes, exactly. Things that are meant to apply everywhere, all the time. Those can be falsified, but never fully verified.
But what about a simple statement like, zebras exist? I can verify that. I just need to find a zebra.
And that's the difference between a universal statement and an existential one. You can verify zebras exist with one observation. But think about falsifying it.
To falsify it, I'd have to search the entire universe across all of time and be sure I never missed one.
Which is impossible.
Yeah.
So for Popper, science wasn't about finding easy, verifiable facts. It was about creating these bold, universal theories that practically begged to be proven wrong.
So this whole process, this method of eliminating errors, Popper saw it everywhere, not just in science labs.
Right. He expanded it into a full-blown theory of knowledge he called evolutionary epistemology. He's basically applying Darwinian principles to the life of an idea.
So trial and error.
Trial and error, or as he put it, conjectures and refutations. Every living thing, from an amoeba to Einstein, is constantly solving problems.
How so?
They generate new variations, a new behavior, a new organ, a new idea, and then those variations face selective pressures. The environment, critics, experimental tests.
So for an animal, a failed conjecture, like, I bet I can eat that poison mushroom,
It means the animal dies. The error is eliminated because the carrier of the error is eliminated.
That is a very high-stakes learning curve. For millions of years, organisms had to literally die for their bad ideas.
And this is where humanity makes this incredible leap. This is the key discontinuity. Thanks to descriptive and argumentative language, we can formulate our theories externally.
We can write them down.
We write them down, we publish them, we argue about them in journals. And that means the theory itself, the hypothesis, can be criticized and destroyed without destroying the person who came up with it.
We let our hypotheses die in our stead. That's his famous line, isn't it?
It is. And it is a staggering evolutionary advantage. It's the foundation of all rational thought, all science, all progress.
Which is why the freedom to criticize, to speak freely, to propose weird ideas is so fundamental to his entire worldview.
Absolutely. If you can't criticize an idea without fear, you revert back to that primitive state where a bad idea can get you killed.
Okay, so to really defend this idea of knowledge existing outside of our own heads, objective knowledge we can write down and argue about, Popper came up with this model of reality he called the three worlds.
Right, this is his map of everything that exists. It's actually pretty straightforward. World 1 is just the physical world.
Rocks, planets, atoms, energy, material stuff.
Exactly. Then World 2 is the internal, subjective world of our minds.
Feelings, thoughts, memories, consciousness, our personal experience.
Yep. And World 2 obviously emerges from the physical processes of World 1 in our brains.
Okay, so then we get to the really interesting one, World 3.
This is the world of the objective products of human thought. It's the cultural realm. Scientific theories, stories, myths, symphonies, laws, computer programs.
And the crucial part here, he said, is that World 3 is autonomous. What does that mean practically?
It means that once we create something and put it out there, it takes on a life of its own. It has real consequences and creates new problems that the creator never intended or even imagined.
Can you give us an example?
Sure. Think about the system of natural numbers, 1, 2, 3, and so on. Humans invented that. It's a World 3 object. But once it existed, it created unintended consequences, like the discovery of prime numbers or unsolved problems like the Goldbach conjecture. Those problems are real. They exist objectively in World 3, waiting to be discovered and solved.
And we didn't invent prime numbers. We discovered them within the system we invented.
Precisely. Or think of a modern algorithm running a stock market. A programmer writes it. That's a World 3 object. But once it's released into the physical world, World 1, it interacts with human psychology, World 2, and can create things like flash crashes. These are real, objective problems that were never part of the original design.
And the only way these World 3 ideas can change the physical world, World 1, is through us, right? Through World 2.
Exactly. A scientific theory in a book, World 3, has to be understood by a human mind, World 2, before that human can build a nuclear reactor, which is a World 1 object. Our minds are the bridge.
So let's take that philosophical engine conjectures and refutations and apply it to society. This is the core of Popper's defense of the open society.
And you have to remember, he wrote the book, The Open Society and His Enemies, as an exile during World War II. He was watching totalitarianism consume Europe, and he was trying to diagnose the intellectual disease behind it.
And that disease he called historicism.
Historicism. It's the belief that history is controlled by these giant, unstoppable laws, and that if you're smart enough, you can figure out humanity's ultimate destiny.
Like Marx's scientific socialism, or the racial destinies pushed by the fascists.
Exactly. And if you believe you know the future, it gives you the justification to do terrible things in the present. You can sacrifice generations for a future utopia that you claim is inevitable.
So how did Popper argue against this?
With a beautiful, simple piece of logic. He said it's impossible to predict the future course of human history. Why? Because history is influenced by the growth of our knowledge.
Okay.
And we cannot, by definition, predict what knowledge we will have in the future. If we could predict tomorrow's great scientific discovery, we would have already made that discovery today.
Ah, that's brilliant. It's a logical trap. You can't know what you don't know yet.
You can't. So if these grand utopian blueprints are based on a logical fallacy, what's the alternative? And he proposed what he called piecemeal social engineering.
Which sounds a lot less exciting than utopian engineering.
It is, and that's the point. Utopian engineering demands you tear down the whole society and rebuild it from scratch based on a blueprint. But when people disagree on the blueprint, and they always do, you have to use force and violence to make it happen.
And there goes your open society.
Right, so piecemeal engineering is just applying the scientific method to policy. You don't try to build heaven on earth. You focus on fighting specific, urgent evils. Poverty, injustice, suffering.
You try one small, reversible policy, a conjecture.
You test its effects, see if it worked, a refutation. And if it failed, you scrap it and try something else. It's slow, it's not glamorous, but it allows society to learn from its mistakes without destroying itself.
But this brings us to a really sharp point in his defense of the open society, and one that feels incredibly relevant right now, the paradox of tolerance.
Yes. This comes from a footnote, believe it or not, in the Open Society, but it's one of his most famous ideas.
So lay it out for us, what's the paradox?
The paradox is this. If a society is endlessly, unlimitedly tolerant, even tolerant of the intolerant, then the intolerant will eventually seize power and destroy tolerance itself.
So unlimited tolerance must logically lead to the disappearance of tolerance.
Exactly. So his conclusion is that a tolerant society has to claim the right not to tolerate the intolerant.
But that's the hard part, isn't it? Who gets to decide who's intolerant? Doesn't that open the door for the tolerant society to become a suppressor itself?
It is the essential difficulty.
Yeah.
Popper puts a very clear line on it. He says, we only have the right to suppress intolerant philosophies when they refuse to meet us on the field of rational argument and instead answer with, well, with fists and pistols.
So it's not about the idea itself, no matter how much we hate it. It's about the method.
It's all about the method. If a group is willing to argue, to debate, then we must tolerate them because that's what the open society is all about. But the moment they advocate for using violence to shut down debate and silence their critics.
At that point, the tolerant society has to defend the framework of rational debate itself, even if it means using force to do so.
Yes, it's an act of self-defense. Not to suppress a bad idea, but to protect the very possibility of having a rational discussion at all.
All right, this is where Popper, for me, becomes just fascinating. He didn't just stay in the realm of philosophy. He took his ideas and walked right into the heart of 20th century physics to challenge the giants.
Yeah, he went right after the Copenhagen interpretation of quantum mechanics. Niels Bohr, Heisenberg, the whole school of thought.
And their view was, in very simple terms, that reality at the quantum level is sort of fuzzy and uncertain until we measure it.
That's a good way to put it. They suggested that the act of observation, or even just gaining knowledge about a particle, is what kind of collapses the wave function and creates a definite reality. Popper hated this. He was a realist. He believed particles have definite properties, whether we're looking or not.
So true to his own philosophy, he didn't just argue. He proposed an actual experiment to falsify their claim.
He did, in 1980. It's a bit like the famous EPR paradox. Imagine you have two entangled particles, particle 1 and particle 2, flying off in opposite directions.
Okay.
Now, you make particle 1 pass through a very narrow slit. The uncertainty principle says if you know its position, that precisely its momentum becomes highly uncertain, it scatters a lot.
Standard stuff.
Right. But because the particles are entangled, knowing the exact position of particle 1 instantly gives you exact knowledge of particle 2's position, even if particle 2 is miles away, passing through a really wide slit.
So what was Popper's prediction?
He predicted that if the Copenhagen view was correct, that knowledge itself creates the uncertainty, then just by gaining that knowledge from particle 1, we should see particle 2 suddenly scatter wildly, as if it too had gone through a narrow slit.
And what happened when they finally did the experiment?
The experiment was done by Kim and Shi in 1999, and Popper was wrong.
The universe refuted him.
It did. Particle 2 did not get the extra scatter. Its momentum spread stayed narrow, exactly as the standard quantum math predicted. The physical situation of the wide slit mattered more than our knowledge.
There's something kind of beautiful about that failure, isn't there?
There really is. It shows his own intellectual honesty. He made a bold, risky, falsifiable prediction. The evidence came in, and it showed he was wrong on that point. It's a perfect example of his own philosophy in action. He let his hypothesis die in his stead.
What an incredible journey, from defining what science even is with falsifiability to mapping out how we can improve society with slow, careful, piecemeal changes.
And through it all, his main target was always the idea of certainty. He wanted to shift the entire goal of knowledge. Don't ask, how can I prove I'm right?
Instead, ask,
How can I find out where I'm wrong? That's the only question that leads to growth. Is what I believe to be true actually true? How can I test it? How can I try to break it?
it really is the ultimate engine for growth. Scientifically, politically, and I think even personally, the enthusiastic elimination of our own errors.
And that leads to a final thought, I think. Popper said that our knowledge is finite, but our ignorance is necessarily infinite. So if we accept that, and we accept that we can never truly verify our deepest held beliefs.
What's something you're holding on to today as an unshakable truth that you might be willing to really seriously try and falsify tomorrow?